Hello, is it visible?
Yes, we can see a
Uh,
screen.
1 minute, right? So 1 minute. Yes. So good afternoon, everyone. So I'm Akash Ghosh, and this I'm from Jadavpur University in Kolkata, India, and this is the topic for preparing annotated data on COVID-19 by employing Naïve-based techniques. So this is a work done in the group by in the group of Jadavpur University Bachelor of Computer Science and Engineering. We are pass outs and under the supervision of Professor Dipankar Das. So we had done a group work, and so yes, so this is the flow of presentation. We start with the introduction, objectives, and continue. So first of all, the introduction. So COVID-19 or SARS-CoV-2, as it is called, is a severe acute respiratory system syndrome SARS that has emerged from Wuhan, China, and it is generating a lot of news because it has caused a lot of disruption and it has also caused a lot of deaths, and so it is in all the news. And as a result, Twitter has also seen an unprecedented explosion and a great rise in the number of tweets and since the pandemic started. And these tweets are contain varieties of topics, like from talking about the deadly disease to the statistics to regarding the lockdown and how are people coping with their new activities, etc. So for such a large number of tweets, the need for an annotated data set, like so that we can segregate the tweets into similar or different categories, are highly needed. And and so in this work we try to achieve the same by by the following ways. To so first of all, this is a classification or a classification problem. So we tried to classify the COVID-19 related Twitter data into a specified number of classes, and then to deliver an annotated data set for and then to deliver an annotated data set for the upcoming research work. So to share the annotated data set, these are the objectives. And so for that we used by a multinomial naive-based algorithm, and we and different types of three different data sets were used, and they were designed from scratch using Python to classify the data from some into some predefined classes on the dataset. And so these are the highlights. So first of all, there are three datasets and three novel in-house datasets of 21,000 tweets. So there are two datasets of 10,000 tweets each and one dataset of 1,000 tweets that were considered. And for each type of dataset, different modified versions of Naïve-based algorithm from scratch were implemented, and experiments were done to finalize the methods for optimal number of clusters and choosing the optimal clustering method and etc. And after that, the classification procedure using knife base has been done to fit the purpose. And thus, and we had obtained a good accuracy upon testing, and thus we can say that the model is as well as methods are robust. So now the first data set. So in the first data set, the following is the workflow. So what is being done? First, in the first step, the data pre-processing has been done. So when the data is taken from the Twitter data is taken, and then the pre-processing includes the cleaning of the tweets and removing of URLs, hashtags, and unnecessary tokens and special characters. This is the dataset preparation parts. And then the labeling of the dataset. First of all, the tweets are unlabeled, and in the pre-processing, manual reviewing has also been done, so that, for example, the tweets containing less than 4 words or very low number of words which cannot be reliably used to extract the Twitter data, they have been separated out. And then the labeling part. So in the labeling part, there are different kinds of labeling has been done to generate the labels. So first of all, the data is unlabeled, and the clustering or cosine similarity and multi-class annotations. These have been done to generate a dataset containing the annotations of the tweets. And then finally, the model has been prepared. So their multinomial and complement net-based models have been implemented. This is for dataset one. So mm, data preprocessing and manual reviewing. After that, the data embedding has been done, where TF-IDF vectorization has been used to convert the sentences into their embedded vectors, and then a map of key value pairs has been prepared with words. Words in the tweets acting as the keys and the class labels as values. So in this way, the labeling has been done. So the approaches to tag the given data has been shown. So in the first, in the this is the label generating process. So in the first part, the clustering has been done using KRMS technique. So the first of all, the generation of map between PCA applied embedded data and cluster has been applied, and after, and then there have been found to be 18 clusters by after using PCA, and then the labeling of 18 clusters has been done, and the 18 clusters have been labeled, and in this way the output is the label 6000 tweets. Then after that, the KRMS technique has been used, which solves which is helpful uh, for number of iterations and increasing accuracy, etc. And in the next step, and no, not in the next step, the other part is cosine similarity that has been done. So in this method, the vectors for all the tweets and labels were obtained using the TF-IDF method that I mentioned. And depending on the cosine similarity value of the vector and label, the label, if it was non-zero, then the tweet has been given some label of non-zero value. And finally, the third method was multi-class annotation. So if the tweet contains the label I, then there have been a predetermined set of n labels, and if the tweet contains the label I in between the 1 to n, then the label has been annotated as the label I. For example, if the tweet contains the words which are present in label 3, then it has been labeled as 3. So now we come to the second dataset, the dataset 2. So here, collection of here, first of all, the tweets have been collected as usual, and then 1,000 clean tweets have been the tweets have been cleaned, and the final collection includes 1,000 clean tweets. And after that, the tweets are again labeled in order to fit them for supervised learning and the classification, that is supervised learning. And then kinds of clustering have been done to on the basis of first of all, the cosine similarity matrix has been generated on the tweet dataset, and then two kinds of clustering has been done for the labeling. The spectral clustering has been done, and another, the k-means clustering has been done, and then the tweet data has been generated, and then naive-based classifier is used for the training and testing. So for the trained dataset, the naive-based classifier has been used, and then after that, the accuracy detection, etc., has been done in the result part. So now we come to the third data set. So the third data set consists of 10,000 tweets as in the first, and then the data crawling has been done using TweetP, and they are stored in CSV file, etc. So in the extraction process, the tweets were from until May 2020, and the time of collection was up to May 2020, and then collection of the most 10,000 most recent tweets up to that date were taken, and then we filtered out the retweets and cleaned the tweets as usual, and then the first 100 tweets have been manually labeled and stored in a file. So Naïve is applied to the manually labeled data, and then spectral clustering has also been used for generating the labels after that, and labels are auto generated using the spectral clustering method. So okay, so this is the module wise workflow of dataset 3. So tweets are collected and then cleaned, and then they are stored in the CSV file and that. Uh, so naive have been applied and the COVID test data has been generated, and in this way the naive analysis has been applied. So the input labels have been created using hand labeling and also using spectral clustering, and so the labels generated by the naive-based algorithm has been checked with the spectral clustering generated labels, and then the accuracy between the trained dataset include the labels. One part is that hand labeling, another part is spectral clustering. So the the final naive-based output, the test data has been checked with the spectral clustering to check the accuracy, and then the results are output. So we discussed the naive-Bayes model a little bit. So multinomial naive-Bayes is just a classification technique that is based on Bayes theorem, and the documents are taken as a bag of words representation as a collection of words, and then the the documents are can be represented by a by a document D here we can consider, and then the feature, the words and phrases here are the features, and the feature probabilities are independent given that the document is document generates a class C. For example, the not generates, so document D and document has been given a class a label or a class C, and the naive-Bayes model here assumes that the feature probabilities are independent given a class C, and conditional probability is there the feature that needs to be calculated of belonging to a class C given the document D that is to be calculated. So okay, this is the base theorem, the basics for two events C and B, and the probability that both the events C and B occurring together is given by P, probability of A intersection B, and probability of conditional probability of B given A is that is the standard base theorem, that is is the product of conditional probability of A given B into probability of B by probability of A. And so in this way, the probability of both events occurring together, probability of A intersection B, can be calculated from this point. And in the context of the naive-Bayes classification, so C is so as I had mentioned that D is a document and C is a class on the label of the document, and given the document D, the probability of it belonging to class C has been calculated using Bayes theorem, and now the fine for each class, for example, there are a set of classes for 10, there can be 10 classes, for example. For each class, the probability of the document belonging to the class C has been calculated, and now the class which is assigned to the document is given as the maximum of the given products. So probability of C into product of probability of X, where X is a feature in the document, given C. This product, the maximum of this product will be the class level, that is, will be the class level of the given document. So now we come to the experiments and results part. So the experiments have been conducted on the three data sets, and the observations are grouped into three different sections. So here we see the data set one. So here are the, first of all, the clustering was done to generate the levels, and there are 18 clusters on the data set. Here are using the KRMS technique, the clusters and the centroids have been computed and shown in the figure. And in all different models, complement naive-Bayes has been found to work better relatively because they are designed to handle datasets which are class if balanced, and the accuracy obtained using the cosine similarity level tagging of the three methods, that the cosine similarity level tagging or cosine similarity method of leveling has been found to be higher. So here are the performances of multinomial Gaussian and complement depth base using the three different kinds of that labeling. So the cosine similarity, what the cosine similarity leveling in the third figure in this figure, sorry, the cosine similarity for the second figure has been found to be the highest using fivefold cross validation, and the model is complement naive base for most of them. For example, here the complement naive base has the highest accuracy. For the others, the multinomial naive base and complement naive base may be equal, but mostly the complement naive base has been found to have the higher accuracy in general. And also there has been some analysis of the most incorrectly predicted words which are present. So here are the incorrectly predicted words, and also using the KNN cluster and cosine similarity, the incorrectly present words have predicted words have been shown. So, and here are the predicted results with frequencies. For example, the news has been present in 300 of the final label data sets, while health, date, etc. has been present in a high number of data sets, while sanitizers has been present in very low number of data sets. So again, this is the performance of the of these labels with respect to the three techniques: clustering, cosine, and multitag on the first data set. So again, we find that so here in this slide, here actually the naive base models were the performance of the models were seen, while here the different kinds of uh, the different kinds of techniques for leveling the data, these have been computed for the these have been computed. So we find that cosine similarity is generally better. Multitag can be better for the Gaussian neighbors, but uh, the best results have been given using the cosine similarity here for 0.8 higher than 0.8 accuracy. So the dataset 2, here in the dataset 2, two methods were implemented: spectral clustering and k-means clustering. And after that, the number of classes for the clustering which were presented as input, the number of classes were changed from 5 to 15, and for each the number of classes were calculated. For the number of classes, the accuracies were calculated for 5 to 15. So so these are the labeled parts and these are the input parts. So here in each such class, 70% of the total dataset has been considered for training and the rest for testing. So here we find that the accuracies have been shown here. And for the second part, the number of classes has been used from 2 to 8. So now, the first of all, this was the whole data set, and here the data set consists of only of 100 tweets, which is divided into the trainer test sets of ratio 1:4. So known output as the most optimal number of classes, 4 in this case, and then the so here are the lower number of here there are lower number of tweets than the previous one, and here there is a higher accuracy percentage for different kinds of clustering methods. So for example, number of classes 5 is 100 in spectral clustering, and number of classes 3, so both are giving very good accuracy in general. So both methods generally give very good accuracy here. And here has been a table which has calculated the most frequently used words in each class. So each of the 10 classes with spectral clustering. So most frequent words and the suggested class labels has been shown. So if the words are like China, pandemic, cases, COVID-19, etc. So here the labels has been generated as COVID impact on Asian countries, which okay, and funds, news, etc. COVID vaccination. They positive report tested, etc. For each of these, the most frequent words are for these words to be the most frequent. The suggested class levels have been shown. And now we come to the dataset 3. So here the first 100 tweets have been manually labeled, and here are the four classes were predetermined for manually labeling. So the tweets are manually labeled and only into four classes. There were mm, for into four classes only. And so using manual labelings, the tweets were classified as this as shown, and the probabilities of were taken all as inputs, and then they are stored in a list. And these are and so for this case, the monograms, bigrams, and trigrams, group of one word, group of two words, and group of three words, have been hard coded into the list. And here are the monograms, bigrams, and trigrams that are shown. For example, cases, deaths, hospitalizations, these are on monograms, social distancing, recovery rate are the bigrams related to the dataset, and trigrams are the is the case fatality rate. Trigrams are low because there are not many large number of trigrams, so classification accuracy has been calculated to be 86%. And here is the word cloud that is shown on COVID dataset 3 generated using Python. So we can see that the COVID is of course the most common word in the tweets. We can find out the most common words, the less common words, etc. So there are some words which, for example, vaccine here. So vaccine can up to VSCCIN. After that, it can be vaccine or vaccination or a different number of words that can be present. So this in a nutshell shows shows that the words which are the most frequent and the in present in the tweets, and the that appear larger here, and the words that are less frequent, etc., then those appear smaller, and etc. So for the visualization purpose, we had made some sorry we had made some clustering. So for the 2D here, these are the tweets, and this is we show the clusters clearly here, and in the three dimension it is more clearly understandable the different clusters and how the and so in these n clusters they have been done these n clusters have been done using k-means. And after the clustering, we inputted it into the naive model and then generated the outputs. And this is the silhouette score that has been shown between the n clusters and silhouette score. So the conclusion. So a naive algorithm has been developed for COVID-19 classification, COVID-19 classification of COVID-19 tweets, and and we collected an in-house dataset consisting of 1,000 tweets. For two two datasets, one of 10,000 tweets and one of 1,000 tweets that was there, and this subsequently assigned them different classes using spectral clustering and k-means clustering and also some hand labeling, etc. And then naive-based classifier classified the tweets. And the first of all, the labeling has been done using these clustering methods, and then name-based classifier classify the tweets into various classes. So the scope of future work, this has been shown. So so these are some basic models, and we hope to improve it by collecting more tweets related to COVID, so that for a large data set, with a larger data set, we can train the classifier better. And that is our aim. And with more classifiers and perform a comparative study with other classifiers for classifying dataset, and to use more clustering techniques like k-means and experiment them with different number of classes, and to compare accuracy obtained by these different methods and find out the optimal number of classes that are required. So these are the references that are shown, and and then thank you here, thank you, and they are here are the email addresses. So
Okay,
okay,
thank you very
thank you.
much, Akash. That was an interesting presentation there. Really, the general public tend to social media, especially Twitter, to express their views and emotions concerning the COVID-19 pandemic.
Hmm. Hello.
As a follow-up question, can you kindly elaborate, like, how did you manage some misinformation, like when you were cleaning your data?
Okay, so we did not particularly work on the misinformation part. We just took the data, and then we classified them into the different kinds of data. So misinformation may exist in terms of uh, false numbers, or false, for example, false keywords, etc., like hydroxychloroquine. But we did not try to find the misinformation part, and that can be a scope of future work. And we can, for example, we can create some classes like of the tags which generate more misinformation data, like false keywords or false data that is being gathered, etc. For that, uh, we can expand the scope of our work in the future. For false keywords or on for example, for false keywords or false medicines, the such labels can be generated, and then we can combat it.
Okay, thank you very much. Any other questions or comments from the other participants? Any questions for the presenter? Okay, it seems we are good.
Okay.
So, yes.
1 minute. So I how can I stop? 1 minute. How can I stop? No. Okay.
Like stop sharing.
Yes. Is it stop sharing now?